Okay, guys, so we look at the example of the polyfunctional and the bifunctional. Okay, the synthesis of the polyamide illustrates both groups of the polymerization reaction. As we can see, the presence of the NH2 in this first monomer, both monomer structure have NH2 at the end of the monomer. And the second monomer involve functional COOH and the functional group COOH to produce a nylon. So if the monomer contain more than two monomer, so we call it as a polyfunctional. For this type of reaction, they only have one monomer. Okay, so we call it as a bifunctional monomer sebab dia ada two different functional group at a monomer reaction. Okay, dalam satu monomer ni dia ada dua functional group yang berbeza. So reaction of amino acid with themselves. Sebab tu kita panggil dia self condensation. Okay, polycondensation. The polymerization of two monomer with different functional group given by AA and BB. In this type of system, it is important to carefully control the stoichiometry of the reaction mixture so that long polymer molecule can be formed. So, stoichiometry means that how much the number of monomer AA and monomer BB to be incorporated in the reaction to produce high conversion. So what is conversion? Conversion is how the functional group react, which berlaku saling pertukaran. How we can produce A, B, B monomer. Okay, AB polymer. Okay, an excess of AA and BB will limit the molecular weight of the polymer that is obtained. For example, we have AA, which is monomer that contain the same functional group react with BB, the second monomer that contain other functional group. So we have the tendency to produce a polymer with the repeating structure of AA and BB. So if we have the two different functional group in a monomer and it react with the functional group that in the second monomer that have same functional group, so we have the tendency to produce polymer with AA, BB and AA and so on. Okay. Now we look at the self-condensation that involve a bifunctional monomer. Okay. We have two different functional group. Kita ada dalam satu monomer ada dua functional group which are, for example, functional group A dengan functional group B. For example, in the preparation of polyester from monomer HORCOOH, so the hydroxyl, which is OH from one considered as A monomer, A functional group, react with the second functional group, which is carbonyl COOH from a second molecule to produce an ester linkage and water. And the polymerization proceeds until very long polymer chain are formed. Okay, in theory, all of the monomer in the reaction medium could react to form a single long polymer chain. Now we look at the classification. The monomer for step growth polymerization. If each reactant have one functional group, no polymer because no functional group at the end of the line. Okay, so kita tak boleh produce polymer kalau dia hanya ada satu functional group. So at least dalam step growth polymerization must contain two functional group. Kalaupun dia ada satu monomer kan, tapi dia mestilah ada functional group yang berbeza dalam satu structure monomer tu. For example, bifunctional. Okay, kalau dia hanya ada satu structure, kalau ada NH2 sahaja kan, NH2 lepas tu dekat hujung monomer tu pun dia NH2 dalam satu monomer tu, dia tak boleh jadi polymer. Making polymer by step growth polymerization. How to make polymer by step growth polymerization? Each monomer must have at least two functional group, and the monomer containing more than two functional group will make branch and network polymer. So this one is the typical pathway for a linear functional group. Kalau kita ada AA plus BB, okay, satu monomer yang sama functionality react dengan monomer yang kedua which have the second functionality, dia akan produce 2 more and the possibility can produce 7 more and polymer in this kind of structure or configuration of the monomer. For self-condensation, okay, they have a tendency to produce more simple polymer, okay, more linear, okay, linear polymer. So condensation with polyfunctional monomer more complex to produce a branch and cross-link polymer, which is thermoset. Okay, classification of step growth polymerization. We can classify into two, which are condensation, which involve the elimination of small molecule, and non-condensation, which is the liberation of small molecule. It's not a byproduct. Okay, for example of the condensation polymerization is amidation, okay, esterification, okay, ester interchange. For the non-condensation polymerization, actually there are an addition polymerization that are step growth polymerization. Polymerization may occur by the ionic addition of monomer or by the oxidative coupling. And the mechanism of this polymerization may be any of addition polymerization, okay, but the kinetic are step growth. For example, in the preparation of the polyurethane, okay. So polyurethane is actually we consider as a step growth polymerization sebab dia guna kinetik yang dalam step growth kan. Tapi dia punya mekanisme dia adalah by the addition. Maknanya monomer tu dia add into the monomer. So that's why because of the polyurethane, sebab tu step growth ni kita tukar kepada condensation reaction. Nama lama dia step growth. Okay. Tapi sekarang kita dah tukar dia kepada condensation polymerization. Kalau secara generalnya dalam polymerization of polymer ni memang kita ada dua, condensation polymerization dengan addition polymerization. Okay. Nama lama dia step growth untuk condensation. Yang nama lagi satu tu memang remain lah, addition. So it means that high molecular weight polymer is obtained only at the end of the polymerization process for the non-condensation polymerization. Normally the polymerization occur without the elimination of small molecule. Dalam preparation of PU dia tak ada produced by product. This one is the types of polymer produced with the example of the monomers. Okay, and the byproduct produced. As we can see, the polyamide, polycarbonate, and antipolysulfone produce byproducts such as water, hydrochloric acid. Okay, we have an alcohol. For the polyurethane and polypropylene oxide, it has no byproduct. Some important step growth polymer are polyamide, polyurethane, epoxy, phenolate, polycarbonate, polyester. This one is the example of polyamide or nylon. Okay. Polymerization become diffusion control very quickly, so a number of polymer chain growth at the interface in the preparation of the polyamide. So the nylon rod trip do not need stoichiometric equivalent. This method can also be used for the production of polyester and polycarbonate. This one is the preparation of nylon rod trip. Involve the adipic acid and hexamethylene diamine. So it will produce a water as byproduct at the bottom of the interface. This one is the adipo chloride and hexamethylene diamine to produce a nylon 66. This one is the preparation of polyester. Involve the nucleophilic addition of OH group to attack the carboxylic acid structure. This one is the mechanism of polyester. Example involve of the monomer diacid react with diol and the presence of COOH, okay, carboxylic acid, to produce part of a polyester molecule, and don't forget about the byproduct. We have this polyester to produce polyethylene terephthalate. As we can see, it have ethylene glycol contain same functionality in a monomer group, which considered as AA and BB. Okay. So all you have to do, you must know how to write the structure. Okay. If I ask you to draw the polyethylene terephthalate reaction, so you can refer to this slide. This one involves the aromatic reaction. Ionic X star is ionic species, and G is the monomer with the functional groups. This one is the example of the polyamide, and this one is the reaction is catalyzed by water, which begin with the opening of the caprolactam ring. Means that caprolactam is the types of polyamide, and it produces byproduct during the reaction, and the water itself can react with the monomer back to produce a nylon. Okay. So the linear molecule produced in polyester will react with more caprolactam, producing a dimer. So reaction will continue between the growing polymer and more caprolactam. Means that in order to produce the nylon 6, it must react with the water. Okay, water react with the caprolactam to produce a nylon 6. But if the water must be removed from the reaction. Okay, this one is example to prepare the polycarbonates. Polycarbonates are a special class of polyesters that have the general structure of bisphenol A and phosgene to produce a polycarbonate. Okay, this one is a special case for polyurethane. Okay, this one is non-condensation polymerization made from the reaction of isocyanate and polyol. So isocyanate is given by NCO both at the end of the monomer structure, and we have a hydroxyl group for the second structure, and basic reaction is between the cyanate group and the hydroxyl group, and this one is the general structure containing the isocyanate. Okay, isocyanate is given by NCO, and the polyfunctional N group can cause the undesired cross-linking. So in the preparation of polyurethane, it has no byproduct form. Okay, this one is the reactivity of functional group, right? If we have monomer, we can produce a dimer. If the dimer react with the monomer, it can produce a trimer. Then trimer react with the monomer, can produce tetramer. Tetramer react with the dimer, dimer and dimer can react together to produce a tetramer. If trimer react with dimer, it can produce a pentamer. Okay, di means 2, tri means 3. So pentadimer lah kan. High molecular weight are obtained only at the end of the reaction. So don't forget the presence of byproduct. Only the preparation of polyurethane tak produce air. Okay, ataupun HCl ataupun OH. Right. This one is the same slide. Okay, I will explain in the next part.